unlikely to break my habits.
Oh, this is nice, then. So you can actually save your training video.
That is the theory, is that I'm going to make the training video and then save it and then decide how it looks and how it sounds and whether it's going to be useful to everybody.
Please send it to me.
Okay. So we are talking about generation and electrical distribution. So we've got steam turbine, and a generator. What is the output of the turbine generator?
3200.
23,000. What are the components of generator action?
Stator, something like.
I don't know. This is a standard like mechanic equipment level test question. This is
Okay.
something that's going to come up.
So you got the rotor, the stator, and
Exciters.
Okay. Rotor, stator, exciter. This is not bad. So when we say the exciter and the rotor together, that's like a magnetic field, right? And then the stator is the conducting bars, and then the thing you're missing is the relative motion. So you have a magnetic field that moves across a conductor, and that creates a voltage. So you got a rotor. It's rotating that way. And we got an exciter. So that is like a loop of wire going around it, right? And that creates a magnetic field, and you're flowing from positive, negative, and we're going that way. So this side's north. I'm only like 70% sure that I got that right. So then that makes a magnetic field. It loops around like a butterfly. Okay, then we've got the stator. How many phases of electricity do we make?
60
60 what's?
hertz.
60 hertz. That's not phases. But yes, 60 hertz is a correct answer
3 phases.
to a question. 3 phase. All right. 3 phase electricity.
Man, you woke up here flipping.
yeah,
So
positive.
you got an A and a B and a C. And then this is like the other end of the same loop, right? So it goes through the board and it comes back out. And that goes, so there's loops of wire that make up the stator going around the generator lengthwise. That makes sense? We together? All right. So all right. I have enough colors to do what I want. I'm going for it. I haven't done this in a while. So, A. B. You guys let me label that wrong. That's right, I'm blaming you for stuff that you have never seen before. C. All right, so when the north end of the magnet is by the A conductor, then it is at a max positive. So that's where this is right now. And as it turns clockwise, this, then the alpha voltage is going to be going down, and the Bravo voltage is going to be coming up. And then when it gets to here, then you're at that point. The Bravo's at a maximum, and the Charlie is, let's see, that's north. And the Charlie is negative, but getting less negative, because as the south moves away from it. Whew. All right, so that's three-phase electricity. That's an exciter and a rotor, and three-phase conducting. And the books will like to say 120 degrees apart, which is obvious because there's 360 degrees in a circle and there's three phases, so it's not freaking rocket science, but something they like to throw in there. All right. So we got a positive and a negative voltage going into that loop that makes the exciter. Where does that come from? How? Good way of asking that.
Alternating current.
Okay, so we're making an alternating current, but the exciter has a direct current on it.
That's the box downstairs, right? On the first level?
Yes. Hang on.
Cabinet?
So on the second floor, there's an excitation breaker. And on the first floor, there's an excitation transformer. So the excitation transformer comes off this 23,000. And it's got a transformer, and then it goes to a voltage control cabinet, which puts DC voltage on the exciter. But yes, you're talking about ground floor behind the condensate strainers? Yes, that is where the excitation transformer is. And that has taken this 23,000 down to 700. I don't know why they picked that number, but that's what they did. And then that goes to a rectifier, which changes it from AC to DC. And then voltage regulator, which is trying to maintain that 23,000 on set point, and will get stronger or weaker, whatever it needs to do to make that happen.